students, welcome to Prime Educare, a institute for JEE and NEET quota. So basically my name is Charul. I am your physics faculty. I have been teaching for more than 5 years and I have taught more than 25,000 students so far across India and abroad. So in today's lecture, we are going to study our first topic, that is physical word units and measurement. Now, if we come across the word physics, so physics, if we talk about student physics, many students are afraid of it because physics is a very tricky subject, but you don't have to worry about it. In this, first of all, what do you understand? Why we always say that physics is a branch of science, but what is the meaning of physics? Physics is basically a Greek word which derives from physis, which means nature. So in physics, we deal about the nature, the laws of nature. We study about the matter. What is basically a matter is, what is basically a matter? A matter is something, anything that has mass and occupies space. So that is matter. So anything that has mass and occupies space is a matter. Like this pen is a matter because it can occupy space. Now we also study about the object energy. So what do you understand by the term energy? If for example we can relate it to a very simple example, like on a racing track. Like on a racing track, there are 5 individuals. On a racing track, there are 5 individuals. So we know that everyone has the different capacity to run. It's not like that all the 4 individuals will be able to run at a single speed. They all have a different capacity, they all have the different energy in it. So we study about also the energy, about the matter, about the forces, motion of the object, and the interaction between them, like how all they are all interacted, like how the force is related to the energy, how are all they interrelated. So we will also learn in detail, don't worry, we will also learn in detail about the other phases of physics. There it's not only like we deal about the motion energy, we also deal about the other things that happen in nature. So physics is like the subject where you can easily relate to the nature, like how the things are happening in the nature. Like the light is lit, so there is a light in the room. So how is this light is generated, where is it coming from, how much amount is the light generated to impart it to a city, and then how is it transmitted to the various locations of the city. So we all study in this all comes in physics. Now mathematics is a language of physics. So whatever concepts you have regarding physics is related, is we can simplify it using, we can simplify all these physics concepts using maths. For example, if the object is running, like if we have an object of mass m and it is running, it has certain acceleration to it. Now what is the force imparted to it? Like if this object has mass m and it has certain amount of acceleration to it, like we have to impart, we have imparted a certain amount of force to it. Then what is that force is? That force is directly proportional to mass and acceleration. So we have simplified, we have calculated this force using the concepts of using mathematical. So we simplify all these physics concepts using maths. Now these laws of nature are understood and expressed mathematically. This object of mass m, it is moving with certain acceleration, the force acquired, how much it will be covering the distance, like at where it will land, where will it stop, like it started with a zero speed, where it will be going to, how much distance will it be covered. This all we solve using maths. So this is a very basic example we take in physics. Like if this object is mass m, it is capped on the table, it is going, is this traveling with a certain acceleration, how much distance will it cover, at what velocity it will acquire, at what distance it will go through, we all cover using we all simplify using maths equations. So we apply, we solve, we derive certain nature's law and we simplify using the concepts using mathematically. Now next come laws are universal. So it's not like that these laws will be valid only in Rajasthan. These laws are not like that, like whatever the physics laws come across, whatever the physics laws we will be coming across, it will not be like that these are laws are only applicable to certain universe. It is applicable to all the all the nature of this world. It is not like that it will be valid in only one part of the reason, it will be valid in all the part of the reason. Now two main thrust of physics is, one is the unification and the other is reduction. So what is, do you understand by the term unification? Unification, students, means that whatever we study, we apply it to a, whatever concepts we study, we apply it to a broader terms. For example, we come across gravitational law. So gravitational law, it is the force which acts between the masses. So so this law, it does not mean that it simplifies only one concept in physics. It is not like that it will simplify only one concept in physics, it will be simplifying other concepts also. So what is unification? To explain different physical phenomena using a set of fundamental, like we have this this basic phenomena which is gravitational law, we have this basic gravitational law. So using this gravitational law, we solve the force that is applied between the masses, force that acts between these two masses, force that is applicable to the earth and the planets, to the earth and the other planets, like we have earth and we have Mars. So these forces, gravitational law will be also acting between this earth and Mars. So this is not like that, this one force, gravitational law, it is only valid for these two objects masses. It is valid for larger mass also, for planetary motion also, like how the forces are acting between the planets. We solve various concepts using gravitational law. So this is what do we call as the unification. So where we apply one concept to various phenomena around the world, where we apply a one concept of physics to various other phenomena. So like gravitational law, like forces that acts between small masses, force act between that acts between planets and the interplanetary motion, we apply the gravitational law concept there also. Now students, next come the concept of reduction. So what do we understand? So let's understand what do we understand by the reduction. So what do you understand by the reduction is that, like when we are solving a certain physics problem, when we are solving a certain physics problem, like we have an object here. So when we are solving certain physics problem, object is here and this is the subject surface. So when the object is dropped, when we have dropped this object, when we have dropped this object, now this object, if we simplify this in nature, then this object has many problems. This object, when it is falling down, it is not only that it will be only be acted, means the force, gravitation force will not be only acted, there will also be the, now if we have to solve this, now it's not like that the only gravitational force will be acting on it. It will not be like that only the gravitational force is acting on it. There will also be the air particles, there also will be the air particles in it which also apply the resistance force. So there also will be the air particles which apply the resistance force. So now if we have to find like what is the distance covered by it, so it becomes difficult, because it will not be only not it's not only like the case that there is only gravitational force which is acting on it. Like when we have dropped this object from a certain distance, so it's not like that that only the gravitational force is acting. There is also the air resistance. There is also the air resistance, like the force which is caused due to the air resistance. So the distance, it will cover, it will, the air resistance, gravitational force, both will affect on it, both will have the effect on it. So the distance covered will have both the effects, gravitational force and air resistance. So we have to simplify it. So what we do in physics to solve various complex problems, we simplify it, that okay, we consider a a simple case, like take a ideal case, we take an ideal case where we are neglecting this air resistance. So let's ignore this air resistance, like there is no air resistance, there is only this gravitational force, and then we simplify the various concepts related to it. So this is what do we call in the physics the concept of reduction, where we simplify a complex situation, complex problem. Like when this object is dropped from a certain height, we are ignoring this air resistance, only the gravitational force is acting. So we are ignoring this air resistance, only the gravitational force is acting. Similarly, like if we if if let's consider another case, when an object is kept on the ground. So when we have an object kept on the ground, so like this is an object which is kept on the ground on mass m. So what we do, we have applied a force to it. Now we have applied the force to it, then what will happen, you can relate it to the nature. Like when we have a certain object kept on the table, let's consider your pencil box. Now when this pencil box, when we are applying force to it, now this surface on this surface will also be applying a force in the reverse direction. This surface will also be applying a reverse force, because this surface will also be applying a friction force, because this surface is not smooth, this surface is not plane. So it will also be applying a force in the reverse direction, a frictional force will be applied to it. So we are ignoring this force, we are only considering the that this force is applied, and this, then we calculate the total distance traveled and the mass of the object. So this is what do we call a concept of reduction, where we simplify a complex problem in physics into simpler parts. Like in this case, let's consider this case again, where we are ignoring that there is no friction to it, only we have this external force, only we have this force which is applied to it, which is an external force. There is no other forces which act on it, there is no other friction on it, there is only this external force on it. Similarly, when the object is dropped from a certain height, we are we are considering a situation that there is no air resistance, only the object is fallen down. Now we have, in physics we have various branches. It's not like that that there is only the one branch in physics where we study. So first let me rub this, then we will study in detail what are the various branch of physics. So students, till now we have the basic details about physics, like what is physics, how do we simplify physics, how do we also then further simplify the concepts of the physics. Now let's talk about the various branches. We have multiple branches in physics. Like it's not like that we have to study only one type of physics. There are many different types of branches of physics. So first let's consider the branch which is classical physics. We have two branches basically, classical and and classical and quantum physics. So we have two branches, classical and quantum physics. So classical physics was discovered very much before than the quantum physics. So classical physics is the physics where we study at the macroscopic level. What is the macroscopic level? Where like this object is kept on this mass m. So here in the practical level we can relate to it. So in the practical level this mass m is kept on the ground, so we can relate to it, like how it will change its motion, how will it distance it will covered, so we can relate to it. But we have in the quantum where the particles are very small inside the atom, inside when we study at the microscopic level, which we cannot see in this practical level, where we use the quantum physics, where we have to use the microscope to study, because the particles are very smaller in size. The particles are at microscopic level, so we have to use a microscope to study like the atoms, and the atoms we have the nuclei. So this all comes in the quantum physics, which is a newer physics. Classical physics is a very older version of physics, where we come across the objects at the macroscopic level, where we can see through our naked eye, where we can easily in the practicality we can relate to it, like how will be the motion of an object, how will be the object force will be applied, how much distance will it be covering, how much acceleration will it be traveling with. So this is all the classical physics. So in classical physics we have also have the subparts like mechanics, we have thermodynamics, electrodynamics, optics. So what is basically mechanics? Mechanics is the how the motion of the object is, motion or the movement of the object is, like with what velocity the object will be traveling, with what velocity will be the object will be traveling, with what velocity, with what distance it will acquire, how much, what will be its final velocity. So this, and what is also mechanics, if we talk about the mechanics students, so mechanics has two parts. Mechanics first part is kinematics, and the other part is dynamics. So we have two parts, where one part is kinematics and the other part is dynamics. Kinematics is the motion of an object, like how much distance it is covering, with what velocity it is traveling, how far it will go. Dynamics is why is this motion, from where this motion of an object is occurring, like why is this motion, like this object is traveling with a certain velocity, like who is the person behind it. Like when we drive a car, we have to accelerate it to improve, to increase its speed. Similarly, this is what we go in the mechanics. When what we study in the mechanics is the kinematics and dynamics, where we study like how much distance it will cover, how far it will go, what is the, now in dynamics we study the cause of motion, like why is the motion is being caused. So we study about the cause of motion. Why is this object traveling, how is it traveling, who is the person behind it, who is actually driving the force. So this we all study in dynamics, while in kinematics we study about the motion of an object, like how much distance it will cover, what will be the acceleration, what will be the final velocity. This all comes in kinematics. Then comes the thermodynamics. In thermodynamics student, we study about the concept of heat and energy. When we have heated an object, like when we have heated an object, then how far we have heated it, how will be the energy transferred. This is what we study in thermodynamics. Electrodynamics, in electrodynamics we study about the electric and the magnetic field. In electrodynamics we study about electric and magnetic fields, where we talk about the concept of magnetism and electricity. We talk about the concept of the electric charges, how the charges will, how the forces acts between these two charges, how is the charge will be accelerated. This all comes in the branch of electrodynamics, where we study about the electric and the magnetic fields. Then comes the optics, where we study about the phenomena of light, where we study about the phenomena of light, like we have the convex lens, we have the convex lens, concave lens. So we study about the phenomena of light in optics. And then comes the quantum physics. In quantum physics we study about the structure of atom, how in atoms the nuclei are placed, how the nuclei are placed, how this nuclei is actually kept in the object, how will be that nuclei will be after some time. So this all we study in the quantum physics. So students, these are all the branches of physics, where we have mechanics, we have thermodynamics, we have electrodynamics, we have optics, and then comes the quantum. So mechanics is the cause of motion, why is this object is traveling, and how fast it is traveling. Thermodynamics is heat and energy. Electrodynamics, electric and magnetic fields. Optics, study of light. And then comes the quantum, where we study about the nuclei and the atoms. Now students, let's go further. Now fundamental forces. Now let's get into much deeper in the physics, where we study about the fundamental forces. So what is a fundamental force? Fundamental force is, fundamental means basic forces, like which are the certain basic forces which we have in physics. So we have the gravitational force, we have the electromagnetic force, we have a strong nuclear force, and then when we have the weak nuclear force. So these are all the four fundamentals of physics, fundamental forces in physics. So basically when we talk about the gravitational force, so what is a gravitational force? The force that acts between the masses, the force that acts between the masses of the object. Like if we have two objects mass m1 and another object of mass m2, then the force that acts between them is m1 is directly proportional to the product of the masses and the distance between them. So the force that acts between these two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance. This is the gravitational force which acts between any two objects. It is very weak force, like its value is very much smaller even than the weak force, but this force acts. Like if the two planets are kept on in the universe, then there is also a gravitational force which is acting between them, which is equal to g m1 m2 by r square. R is the distance between them. Then comes the electromagnetic force. So what is the electromagnetic force? Which force which acts along with the gravity strong? It is also one of the fundamental force, and which is due to the charges and the magnets. The force which acts between the charges and the magnets, that is the electromagnetic force. It is a very strong force, but it is not stronger as compared to nuclear force. So the force that acts between the charges, like if we have the charge q1 and if we have the charge q2, then what is the force that acts between them? What is the force that acts between these two charges? Like if these two charges are kept at a certain distance, what will be the force acting between them? This is a electromagnetic force, which the force which acts between the charges and the magnets. Magnets we have all come across, like we have the north and the south pole. North south pole attract, and if we have the same unlike poles, it repel. Then comes the strong nuclear force. Now students, if you think and if you observe, like we study about the atoms, we study about the structure of atom. So what do we have in an atom? In an atom we have the nucleus. In the atom we have the nucleus. So what do we have in the nucleus? In the atom we have the nucleus. What do we have in the nucleus? We have neutrons and protons. So we have the neutrons and protons. So we know that protons and proton is a positive charge. Proton is a positive charge, so it should repel. Proton is a positive charge, so it should repel. But how all these protons, means there will be an electrostatic force that will be acting in it, but these neutrons, these protons are kept in this nucleus. This exists in the nature. This neutrons and a very good amount of protons and a good amount of neutrons are kept in this nucleus. So how are these neutrons and the protons are kept in the nucleus? How are they in the part of the nucleus? Neutrons and protons, how are they kept in the nucleus? So that is due to a strong nuclear force which exists between them. So these neutrons, these protons, these are kept in the nucleus because a very strong nuclear force is acting between them. So this nuclear force is actually a distance dependent. This neutrons and protons, these are distance dependent. This acts when the distance is very much small, and with it has a magnitude of very higher amount. This force is greater than electromagnetic force. This, because of this strong nuclear force, it is able to bear this electromagnetic force which is acting between the same charges. Because we all know that when we are small, we always play with the magnets. We know that how difficult it was to get the north and north pole together. We know that it used to be very much difficult to bring the north and north pole together, because there was a very strong repulsive force which is acting in it. There is a very strong amount of repulsive force acting in it, but due to the presence of this nuclear force, we are able to bring these protons and neutrons together. This is a distance dependent. This nuclear force is a distance dependent. It is applicable when the distance is very much smaller. Now students, let's go further. So we have another type is weak nuclear force. Weak nuclear force, it also exists in the nucleus, where it also causes the beta reduction, where the neutrons is changed into a proton. Now we talk about the various conservation laws in physics. What is meant by the term conservation? Means its value is not changing. It remains constant. Its value, its magnitude is not changing. That is we call as the conservation law in physics. Its magnitude is not changing. So we have the conservation of energy, where even after, like, this person is traveling, this energy this energy will be transmitted. This energy will be transmitted to another form. So we have the conservation of energy. We have another concept, the conservation of momentum, which is the product of mass and velocity. Which is the product of mass and velocity. It is a vector quantity which has magnitude and direction. It measures how the motion will be. It measures momentum, measures how the motion will be. So we have the conservation of energy, like when we have the two objects on the table. It is going with u velocity, it is going with the v velocity. These two objects gets collide, and after some time its velocity becomes u1 and its velocity becomes v2 v1. So it after collision, so but its total energy will remain constant. Like when they have collided, it's traveling with u velocity, it's traveling with v velocity. Now if these two objects has to collide, if you think it, if these two objects has to collide, then which one has to be at higher speed? If these two objects has to collide, then which one has to be higher speed? Obviously the object first has to be at higher speed, so that it can collide with the second object. So after collision its velocity is u1 and then v1. So its energy remains constant. Then conservation of momentum. Momentum remains constant. Electric charge, we have the charge q1 on the object 1, we have the charge q2 on object 2. So when they are rubbed, when they are rubbed, or when they are means when they are in contact, the total value of this charge remains constant. That is called the conservation of electric charge. When we are rubbed this object, when they are in contact, the total sum of this electric charge remains constant. That is what we call as the conservation of electric charge. Then comes the conservation of angular momentum. And a momentum is the measure of an object in the linear motion. Momentum is when the object is traveling linearly, but angular momentum is when it is rotating. When the object is rotating, we study its motion. Now, so these are all some of the conservation laws which we come across in physics. Energy conservation, momentum conservation, like when there is no external force that is act on it, then its momentum, the measure of the motion, its measure of the motion remains constant. Electric charge, when the two objects having some charges are collided, then the charge remains constant. Then conservation of angular momentum, how when the object is measure of the object when it is rotating. So this we all come across. These are some of the conservation laws in physics which we will come across. Now students, let's come to the units and measurements. We have various terms, like if we go in also in a family, we have various terms for for many relations, for many friends. We have certain terms for it, we have certain names for it. We know that some are means our friends are denoted by a certain name. It's not like that we denote it as, like if she is a female, we denote it as if she is a female. We don't call her as with the name female, we call it with certain name. Similarly, similarly to any relative also, we know that they has to be labeled, they are labeled as with certain names, and we have to say with we have to speak to them with a certain name. So this is how we, in the practical level, we have also used the concept of the measurements and units and measurement to specify certain quantity, to specify certain relations. Similarly, in physics, we also have the certain quantities. In also physics, we have a certain quantities where we also label it. So for different quantities, like we have come across various branches of physics till now. So in various branches of physics till now, we in every branch we have a very different concept. Like in mechanics, we study about the motion of an object. In electrodynamics, we study about the motion of the charge, how the charge will act, how the force will act, then the charge comes in, how the charge has the electrons and the protons. We measure the value of the charges in it. So it has a complete different concept. In optics, we have a different concept. We study about the phenomena of light, like how the light is moving, how the light will converge, how the light will diverge. Similarly, so in quantities to which what is physical quantity, which used to describe the various units of physics. So physical quantity is various which we describe various laws of physics using the physical quantities. So physical quantity are those quantities which used to describe the various laws in physics. Now, first of all, these physical quantities are categorized as scalar and vector. So we have categorized various quantities. So we have first of all physical quantities, all the various quantities in the physics. We have categorized them as scalar and vector. Now what is a scalar and what is a vector? A scalar quantity that has magnitude, that has only magnitude. So we have categorized all the quantities which has only magnitude as scalar. And what is a vector quantities? Which has magnitude as well as direction. Where we talk also about the magnitude as well as the direction, it is called the vector quantity. So what is the example of a scalar quantity? Example is mass, density, volume, time. All these are the scalar quantity which has only the magnitude. What is magnitude? What do you understand by the term magnitude? So let's consider we have a mass of an object which is m kg. So mass of an object is m kg. Let's consider it as 15 kg or 10 kg. So the measure of its value, like this 15, we talk about the measure of its value like this 15. So this 15 is a numerical term. This 15 is a numerical term which is a measure of the mass. This 10 is a measure of the mass. So this is a numerical term which we label it. So this is the magnitude. Like if we have two objects, one is thicker, one is thinner. So we actually can differentiate using the magnitude, like which has a greater mass, which has a smaller mass. So we can differentiate it. Like this 15 kg, it has a greater mass. 10 kg, it has a lower mass. So this can be labeled as. Now, what is a vector quantity? Which has both magnitude as well as direction. Like if we have a 15 kg object, it is going with the velocity in the east direction. Like if we study about the direction, we have north, south, west and east. So when we are talking about its quantity, we are also talking about its direction. When we are talking about its direction, in which direction the object is going, either it is going in east, in north, south or in west. So when we are describing the direction of the object, north, east, south, west, we call it as a vector quantity. We call it as a vector quantity where it has both magnitude as well as direction, such as displacement, force, velocity. So all these quantities are the vector quantities where we are also describing its direction, its motion, where the object is traveling, in which direction it is going. It is going in north direction, south direction, or simply in, if we come across in the practical, it is going in right, it is going in left, in which direction it is going, where we are also explaining it, then it is a vector quantity. So we have also have various laws on it. This topic is not only limited to only the scalar and vector term, where we will have a various quantities in physics and where we will be describing it in two certain terms. It will not be like that case, students. So don't consider it is very easy. We will also be understanding in a much deeper way, like how this object will be travel, how the for example, we let's consider, let's consider a vector quantity. So we have also have certain laws in it, where we also have certain laws in it, such that we have this mass of an object, we have the mass of an object, this is going. Now let's consider, here the force is applied 10 Newton. This is a mass of an object, it is kept on a ground. Now this 10 Newton force is applied on it. Now we have applied this 10 Newton force on this mass m object. So we know that after certain time it will travel and it will cover a certain distance. So when we have applied this 10 Newton force, it has on this object of mass m, it will cover certain distance. But what will happen if this 10 Newton force is applied in this direction, and as well as in this direction we also have applied the 10 Newton force. So when we have applied this 10 Newton force in this right direction also, and also in this left direction, what will happen? If we ask the simple concept, what will happen now? This 10 Newton force is applied in the right, this 10 Newton in left, both the forces will get cancelled. So there will be no motion. So there are certain laws also in vector quantities where we will come across that how we can simplify that. The resultant here is not 20 Newton, the resultant here is 0. So there are certain laws which we will be studying in the deeper in later stage. So these vectors are not limited to only that it has magnitude as well as direction. There are also certain laws which are related to this vector quantity. Scalar which has both, which has only magnitude. Now based on the dependency, we have base quantities and we have the derived quantities. So which are the base quantities which are not dependent on anything? There are certain quantities in physics which scientists and physicists have labeled it to study the various other concepts, to study a complex concepts. So they have simplified certain quantities as the base and the derived. Derived are dependent on base. Base is not dependent on anything. It's just like a simple concept. When we have um, we can relate to it as a simple concept, like we have in our previous classes in 10th and 9th, you have all drawn the y-x curve. So in this direction we have the y curve, in this direction we have the x-axis. So we have the y-axis and this is the x-axis. So we know that the value of y is dependent on x. But is this x is dependent on anything? Is this x, like we have y equal to mx plus c, which is equation. So is this x is dependent on anything? X is independent. Similarly, we have this concept of fundamental and base quantities where it is not dependent on anything. We have simplified very basic quantities which are not dependent, like the mass of an object. Mass, what is a mass? The total amount of matter contained in an object. Like what is the total matter that is contained in an object is a mass. Similarly, we have time. Time running a race. How much time will it be able to complete the race? That is called the time. Then we have the length, like what is the total length covered. So these are some of the basic fundamental quantities which are not dependent, which are independent, and derived quantities which are dependent on other quantities, which are dependent on other quantities, on basic quantities, on these fundamental quantities. So these derived quantities are dependent on the fundamental quantities like the volume, acceleration, force. So force is dependent on mass and the acceleration. The force is dependent on the mass and acceleration. We have pressure. So all these are the derived quantities. Okay, students. So I hope till now you have understood. We have gone through various concepts in units and measurements. So let me recollect it. So it's too much now. So let's recollect it what we have studied till now. So we have first of all physical, how the scientists have gone through it, gone through the concepts. Like it has they have described as the physical quantities, like the quantities which we measure in the physics. Then there is a categorization based on their directional properties, such as the scalar and the vector. What is a scalar? Which has magnitude. Vector, which has magnitude and direction. So they have labeled in these two, because the quantities which has the direction, they follow a certain other properties, certain other properties. For example, like we have gone through the force example. We can also get into one more example. Like we have, let's say this is 10 kg object which is kept on the ground. Another object is kept which is 20 kg object. So this 10 kg, 20 kg, when they are together and taken, it will be equal to 30. But it will not be like it will become 10. So this is a mass. Here we are talking about the mass which has a certain concept, which is a scalar quantity. But when we come across the force, we have the mass of an object, 10 Newton is applied in this direction, 10 Newton is applied in this direction. So net force cancelled. Net force gets cancelled in it. So this is what we call as a vector quantity, where the net force gets cancelled. So it follows the properties of the vector quantity. It follows the properties of a scalar quantity. The mass is added. Here it is, the total net force will be 0. So it follows the property of vector quantity. And here it follows the property of scalar quantity. Now, based on the dependency, we have the fundamental basic units which are not dependent on any other quantities like mass, length, time, and derived quantities which are dependent on base quantities like force, temperature, force, pressure, volume. These are dependent on fundamental quantities. Now, let's solve this numerical, students. Let's solve this, let's understand it, what is this question is talking about. I will give you all 15 seconds to think it, and then we will solve it. So what is this numerical speaking? It says that we have to classify the various quantities, like these are the quantities we have: displacement, mass, force, time, speed, velocity, pressure, and work. We have to describe these quantities into these four categories. So which comes under base and scalar? So which comes under base and vector? Then derived and scalar. And then derived and vector. So now we have the certain physical quantities given. Now we have to describe it in these four categories. So first of all, what is we all have, I think so, we all have understood the concepts of scalar, which has only magnitude, vector which has magnitude and direction. We have the concept of base quantities. We have the concept of derived quantities, base quantities which are not dependent on any other thing. Then we have the derived quantities which are dependent on the base quantities. Now students, now let's classify these quantities in base and scalar, base and vector, and derived and scalar, and derived and vector. So first of all, we have the displacement. So what is a displacement? That has magnitude and direction. So where this will be coming? So displacement is the length of an object. So then the distance covering, so it will come in base and vector because it has magnitude as well as direction. So displacement is a base and vector. Mass, mass is the amount of matter contained in an object. So where it will be coming? In the base and scalar. Then the force, force is a derived quantity. Derived quantity because what is force? It is mass acceleration. It is dependent on mass. What is mass? Kg. Acceleration, if we talk about what is acceleration, it is meter per second square, length per second square. So it is dependent on time, it is dependent on mass, it is dependent on the length. So it is a derived, and force is a vector quantity. So it will come in derived and vector. So force. Then comes time. Time is also a base and scalar. It is a base quantity and it has no direction. Then speed. Speed is also, what is speed? Speed, if we see, speed is distance covered per unit time taken. So distance is length and time. So it is dependent quantity. It is dependent quantity.